Hi. Today, we're going to learn how to build a deep learning API that can translate text using FastAPI and Python.
The API will do three things. It will accept a translation request. It'll translate the text on the backend using a deep learning model, and then it'll return the translated text to the client. Let's get started coding. We're going to be using PyCharm, which is a Python IDE, for this project. You can use PyCharm or any IDE that also has a terminal built in. So the first thing we're going to do is we're going to create a new file called main.py. And this file is going to have the routes for our web server. We're first going to mock these routes out before we actually code them. So the first route is just going to be an index route. And this is just going to test if everything is working. So when someone tries to do a GET request to this route, it's just going to return a simple message. So it's going to return a message, hello world. So these are just comments to help us understand what we'll be coding. So route 2 is going to be the translate endpoint. And this is going to take in a translation request. And it's going to return a translation ID. So we're not going to do the translation immediately in the request. And that's because certain long translations can take a while to actually process. And that can cause the initial web request to time out. So instead, what we're going to do is we're going to take in a translation request and then store it to the database. And then we're going to return the ID of that database model. And then on the back end, we'll actually run the translation and update it. So the client can actually query the database using another route to see if the translation is finished or not. So route 3 is going to be / results. And this is going to take in a translation ID, and it's going to return the translated text. So these are going to be our 3 routes that we're going to define. And to support these routes, we're going to need a couple of other files. So the first file is going to be tasks.py. So these are going to be tasks that we need to run on the back end to actually power all of the routes. So the first task that we need to write is actually going to be the store the translation. So this is going to be a store translation task. And this is going to take in a translation request and save it to the database. The second function we write is going to be run translation. And this is actually going to run a pre-trained deep learning model. And the final function is going to be called find translation. And what this is going to do is it's going to retrieve a translation, i.e., there you go. It's going to retrieve a translation from the database. All right. And the final thing we need to actually power this is a database model. So let's actually go ahead and create that model. And for this model, we're actually going to use a library called Peewee. So let's go ahead and install that and our other requirements before we actually define our model. So let's create a new file. This is going to be called requirements.txt. And in this file, we're going to define the requirements for our project. And those requirements are the FastAPI package, which we'll use to actually build our API, UV-icorn, which we'll use to run our API, Pydantic, which is used for data validation to make sure we're getting valid data from our client, Peewee, which we'll use to interact with our database, the transformers package, which actually will run our translation for us, sentence piece, which is used by transformers to tokenize our input, which I'll explain a little more later. and then PyTorch, which is used by transformers to actually run our underlying deep learning model. So these packages are our dependencies, and we can actually open up the terminal and install these with pip install -r requirements.txt. So this is basically going to read all of the requirements in this file and install them. So all of these requirements have been installed. Now we can jump back to models.py and define our database model. So we're first going to, from py, import a few things. So we're going to import model, which defines our model for us, SQLite database, which will create a SQLite database and the right tables, and then two field types, which are used to store data to the database. So we're first going to initialize our database. So we're going to say db equals SQLite database, and then the name of the database is going to be translations.db. So this will create a new file in the current folder called translations.db. Then we're going to define a class called translation model that inherits from model. And basically what this class is doing is it's going to define a database table and the columns in that table. So we're going to define a text column, which will be a text field. So this is the text we want to translate. This is the language we want to translate from, our base language, the language we want to translate to, our final language, and the actual translation. So when we first create each database record, translation is going to be empty because we need to actually generate that ourselves. The client is going to send us these three fields: the text they want to translate, the language they want to translate from, and the language they want to translate to. But we need to generate this. So this is initially actually going to be null, and then we need to actually fill it in later. And then we're going to add a meta class that's going to say use this database to actually store this model. This is something called an object relational mapper. That's what Py is. And it enables us to interact with a database more easily than just writing raw SQL. Then we need one more line, which will actually create our table if it doesn't exist. So that's db.createTables, and then we're just passing in the name of the table that we want to create. So all this code is doing is defining a way for us to interact with our database and actually creating a SQLite database for us to store our data into. All right, now that we have this model, we can jump over and start defining our routes in our main file. So in order to define our routes, we need to import a couple of things. So we're first going to import from FastAPI. We're going to import the FastAPI class and the background tasks class. So we're going to use background tasks to actually run the translation in the background. And FastAPI is just going to be used to create our web server. We're going to import a library called Pydantic. We're going to use this to validate the data that we get as input to our API. It's important to validate because otherwise you can get a lot of random input that causes errors with your program. And then we're going to import the tasks package. We haven't defined any tasks yet in here, but once we do, we want to be able to import them and use them in our main file. Then we just need to say app equals FastAPI, and that will initialize our FastAPI web application. Okay, then we can go ahead and define our first route, which is going to be a get route. So we will send a request using our browser to this route, and it'll return this message, hello world. And this is going to be what's called an index route. So it's going to run at the base of the web server. So when you just put in a URL like www.google.com without a path or anything, this is the route you're going to get. And we're using something called a decorator to actually tell FastAPI that when a GET request is made to this route, then we want to call this function. So I'm not going to get too much into different types of requests, but the two you need to be aware of for this tutorial are GET requests when we're asking the server for some data, and POST requests when we're sending some data to the server to be processed. So this is a GET request. And then what we're just going to do is return this right here, this dictionary. Okay, so we can go ahead and save this. And at this point, we actually have a fully working web server. That's the amazing thing about FastAPI. And we can actually go ahead and test it out by going to our terminal and typing uv-acorn main app -- reload. And this will actually run our web server for us. And what the reload flag does is if we change our web server code, like if we add more routes, it'll automatically reload. So the web server will be updated. So let's go ahead and run that. And it will give us a little URL down here, which we can actually open up in our browser to view our routes. And if we head over to Chrome and this URL, we can actually see that our web server is running. 127.0.0.1 is just a special IP address that refers to our local machine. You could also type localhost. It's going to give us the same result. So our index route is working, which is great, and we're getting this message back. But we still need to define the fun part of our program, which is doing the translation. So let's go do that. So the second route that we write, this translate route, is going to take in some data corresponding to a translation request. So let's actually define the data that it's going to take in. And we're going to use Pydantic to actually define this because it's going to help us validate our data. So this is the data we actually want to take in. We want to take in a field called text, which is going to be a string, a field called baselang, which is also a string, and a field called finallang, which is also a string. And we want to make sure we validate our input because we want baselang and finallang to actually be in the list of supported languages for our deep learning model. So what we're going to do is we're going to create a validator decorator, validator, and it's going to take in baselang and finallang. And we're going to decorate this function called validlang. So if you're not familiar with the decorators, they basically can add additional functionality to a function. And what this decorator is telling Pydantic is when this class translation is created, when we initialize a baselang and finallang on it, pass them through this function to validate that they're correct. So we're going to define a list of languages that our API supports. So this is just going to be English, French, German, and Romanian. And this is due to the specific model that we're using. If you change models, which I'll explain later on, then you can actually change the list of languages that are supported. So what we're going to say is if lang not in languages, raise value error. So what this is basically saying is if somebody sends invalid input to our server that we can't use because our model doesn't support it, then we're going to return an error to them. Otherwise, we're just going to return the language. So this is our data validator that ensures that our route gets proper data. Okay, then we can go ahead and create our route. So this is going to be a post route because we are taking in data and we're processing that data on the back end. So we're going to create a function called post translation, and it's going to take in a variable t, which is going to correspond to this translation model from Pydantic, and it's going to take in background tasks. And what this is going to enable us to do is run our translation in the background. So we're able to return to the client an ID corresponding to the database entry of their translation request. And then we're able to queue for processing in the background that translation request. And as I mentioned before, The reason we do this is if we do try to do the translation within the web request, some long translations can cause errors and won't work properly. All right. So in this post-translation function, we need to do a couple of things. So we need to be able to store the translation, and then we need to be able to run translation in background. And to do that, we need to actually write tasks for each one. So we're going to head over to our tasks file, and we're going to code these two functions up: store translation and run translation. So store translation is actually just going to be a function that saves our translation request to the database so we can process it later. So from models, we're going to import our translation model. And then we're going to initialize that model. So we're going to say model equals translation model. And then we're going to define the fields on that translation model. So baselang equals t.baselang, and then finallang equals t.finallang. So we're taking in t, and what we're taking in is, if we jump back to main over here, we're actually going to take in an instance of this translation class with our validated data. And then all we're doing here is we're storing that validated data to the database. Notice how we're not filling in the translation field because we don't have a translation yet. So that's going to be stored as null initially. Then we're going to say model.save, and then we're going to return model.id. So model.id is what we're going to use to reference our model later, to run the translation and query the translation. So all this is doing is storing our data to the database so we can process it later. Okay. Then the more fun function is our run translation function, and that's actually going to use a pre-trained deep learning model. So we're going to use our transformers package, and from that we're going to import T5 tokenizer and T5 for conditional generation. So the tokenizer is going to turn our text into numbers that our deep learning algorithm can process, and the T5 for conditional generation is going to actually generate translation based on those input numbers. We need to initialize them before we can use them. So we're going to say tokenizer equals T5 tokenizer dot from pretrained. We're going to use T5 small, and we're going to pass in model max length equals 512, which just specifies the maximum length of an input to the tokenizer. So from pretrained means that we don't need to create the tokenizer ourselves. It's already been generated for us, and we're basically going to download it. T5 small is a deep learning model trained by Google that can translate between a few different languages. It's pretty accurate, and it runs pretty quickly. If you want a more accurate but larger model, you can use T5 base or T5 large. I'm not using those just because I want things to run pretty quickly in this walkthrough, but you are welcome to use a more complex model. Then what we're going to say is translator equals T5 for conditional generation dot from pretrained, again, T5 small. All right, so these are the two variables that are both going to turn our input text into numbers, and then from those numbers generate our translation. And they've already been trained. Google has released the pre-trained weights for these models, so we can actually use the models without training them beforehand, which is great. Training these models can take a lot of GPU time. Okay, now that we have our tokenizer and our translator, we can code up our run translation function, and it's going to take in the database ID of a model that we want to translate. And then what we'll do is we'll grab our translation model from the database by using the getById method. So this is the translation model we created using Peewee. We're basically saying query the database for a certain ID of the model. And hopefully you're familiar with databases, but if you're not, an ID is basically a unique identifier for each translation request. So a translation request could have ID 1, ID 2, ID 3. Looking it up by ID will return a single translation request. So we're going to basically assign this to the variable model. Then we're actually going to set up our translation using deep learning. So the way that T5 works is it takes in a translation request that looks like this. Translate English to French, the text we want to translate. So what we need to do is basically change our data to be in this format. So we're going to say translate model.baselang to model.finallang, the text we want to translate, model.text. So this is a format string that will basically generate the translation request for us. So this will return a string with the full translation that we want to pass into T5. Then we need to actually tokenize this. So tokenizing will basically split it up into words. It's not 100% words, but you can think about it like that. And then convert it to numbers. So deep learning algorithms can't work directly with text. They need you to turn that text into numbers. So that's what we're doing here. We're first initializing our tokenizer with the text we want to translate, and then we're getting the input IDs, which is turning it into numbers. Then we're going to generate our outputs based on the inputs using the translator. So we're going to say generate input IDs, and then we're going to pass in max new tokens, which is basically saying the maximum length of the translation that we want to return. Okay, then we have to decode the outputs. So the outputs are going to be numbers, and we actually want them to be letters, characters, words that we can understand. So what we're going to do is we're going to say translation, not translator. Translation equals tokenizer dot decode outputs 0, skip special tokens equals true. So this is going to turn our output from numbers into text that we can understand. And skip special tokens is just skipping some tokens that are used internally by the model that aren't going to make much sense to us. Then we'll go ahead and save the translation to our database. And then we'll say model.save. So this is going to run a full translation and then persist it to our database. Okay, so we can now jump back to our main.py file, and we can finish coding up our translation function. So we have post translation. So we're going to say tasks.store translation t. So this is going to take the translation request sent to the server, store it to the database, and then as a result, we'll get the database ID of that translation. Then what we'll do is we'll run a background task, passing in that ID, comma. So in the background, it's going to actually run the translation, but it's immediately going to return task ID equals TID. So it'll immediately return to the client making the request, but in the background, it'll actually process the translation. And again, the reason we do this is sometimes long translations will cause the server to time out and cause an error. So we don't want that. We want to run the translation in the background and immediately return to the user. Okay, so that is our post-translation endpoint. We can now actually jump over to Chrome and take a look at how this endpoint works. All right. So if we just type translate here, it's not going to work because by default, what happens is our browser is going to make GET requests and not POST requests, which is what our API is actually going to take. Okay, and I made one small typo in my validator. So we're back at main.py in this translation model. We just need to change this to final lang. I had it as final str. So once we do that, our server should work and we can pop back over to Chrome. And what you'll see if we hit the translate endpoint is method.not allowed. That's because we're sending a GET request to the server, and this endpoint only allows a POST request. It's not easy to send POST requests from the browser. You usually use the command line, but luckily FastAPI gives us a much easier way to do it. So if you hit this docs endpoint, this endpoint is automatically set up by FastAPI to help us view and use our API more easily. So we can see here we have two routes, our index route, which always returns hello world. So I'll hit try it out and hit execute, and we can see our message. And then we have our translate route, where we can post a translation. And you can see these are the three fields that we actually need to send to this route for it to work. So what I can do is I can click try it out over here, and that will give me this little editor window where I can type in some text like hello world. I can type in my base language, English, and the final language I want to translate to. And then I hit execute. So we can see this would be the command you run on the command line to achieve the same thing, sending in the request. And then we can see the response that we got back here. So what we got back is task ID 1. So that means that our task has been stored to the database and it currently has ID 1. So the translation should actually be running, but we don't have a way to retrieve the translation. So what we need to do to finalize what we've built here is create a way for us to get the translation back. So that's actually going to be this third route, /results. So for this results route, it's going to be called def get translation, and it's going to take in an integer translation ID. Then what we need to do is we need to write a task that actually queries our database for a certain translation ID and returns the translation. So we'll pop back over to tasks. Under find translation, we're gonna create a function that will actually take our translation ID and actually look up the translation model from the database. So we're again going to use the model equals translation model get by ID. So this is similar to what we did before. Then we'll get the translation field from that model. And then what we'll say is if translation is none, translation equals processing. So basically, when we first initialize our model, so when we're storing it here, translation is none. And then later, after the translation model has finished, then we actually set the translation field. So here, if the translation is none, it means that we haven't processed it yet. So we're just going to return a message that says processing. I'll actually make this a little more explicit. Check back later. And then we'll return our translation. So either we'll get the translation back and we'll return it, or we'll tell the user to check back because the translation is still running. So let me go ahead and save that. Then we can go back to main and we can finalize building our get translation route. So this is going to be pretty straightforward. We're just going to return the translation, which is going to be the result of tasks.findTranslation passing in the task ID. Okay. Okay, now we add a decorator, just telling FastAPI which route this is. So this is going to be the results route. So basically, when we send a GET request to the results path in our web server, we will be able to get a translation back. So let's go take a look at this in Chrome. I realized I was on the wrong screen for a second there. So what we need to add in here is this decorator results that basically indicates to FastAPI that when the user sends a GET request to the web server, call this function. Now we can hop over to Chrome and reload, and we'll see our 3 endpoints. So index, our translation, and our results. So if we hit try it out on our results endpoint and pass in an ID, we can actually scroll down and see our translation. So we can see that we have the translation Bonjour monde here, which I don't know French, but I think is correct for hello world. We can also send in other translation requests. So we can go back here to the translate endpoint, and we can say something like France is a country famous for its wines. And then we can say base language is English, final language is French, and we can execute this. And we get back task ID 2. So we can go down to our results endpoint, stick in task ID 2, hit execute, and we get our results back. This looks correct to me also, but I don't know French, but it looks generally right. So the cool thing about this is you can run as many translations as you want, and they're all stored to the database. So let's go back over to PyCharm, and I'll show you how to access that. So I'll open up another terminal here, a new session. And what we can type is sqlite 3 translations.db, because that's our database name, and it's going to be in the same folder as the rest of our code. So we can do .tables to see the table names, and then we can write select star from translation model, which shows us our 2 translation records. Let's quit that. And we can also look at our web server logs to see what requests are being made to our web server. So we can see these are the 2 requests we just made to get the results, as well as the translation request. All right. So we just built a web server that translates text using an API, which is pretty amazing. There's a lot you can do to extend this. Probably the best thing you can do is try changing these models around to support other languages. So there are models out there that support many, many more languages. There's a couple that support 200 plus languages. So it's worth a try to just see if those models can work. And generally, you don't need to change anything else. You just need to change the translation engine and run translation and here to switch the models in and out. So that's something really cool you can do. You can also see if you can show more of a translation history, like maybe you can show a translation history route. You could also add the concept of users and authentication. If you want people to have to send in an API key, or you want to keep track of who's sending each request. You can also scale this server up to be multi-threaded. Right now it's just single-threaded and runs locally. You can make it multi-threaded or deploy it to the cloud if you wanted more people to be able to use it. And in the next video, we'll actually cover how to deploy this to the cloud using Docker, which is pretty fun. And then anyone will be able to access your translation API. All right, well, I hope you enjoyed this walkthrough, and hopefully we'll see you in the next video.